All right, let's start with 7. And you want to know angle KOL. That was a commonly missed one. Okay. So first of all, you decide what type of angle that is. Oh, that's not a central angle. It's not an inscribed angle. That is an interior angle. So I know to find an interior angle, I'm going to add my arcs and divide by 2. So we need to figure out what our arcs are. ML is 45. KM is a diameter. And KJL is 40. All right, well, if that's a diameter, we know that arc KL is 180 minus 45, right? We know that this one's 135. And now what we're going to need to do is I would recommend that we find this first, which the problem asked for you to find that one first. And the way that you would find that arc is to use that angle, use 40, and use 135. So I know to get angle 40, to get that angle, I'm going to subtract my arcs and divide by 2. So now I'm going to work backwards. 80 is 135 minus x. And so let the x and the 80 trade places. So 135 minus 80. And that means that this is 55. What I recommend you do, well, there's a couple of ways. Let's go ahead and just find that last missing arc, okay? So we're going to use our diameter. We're going to do 180 minus 55. And we're going to get this arc right here. It's 125. So how are we going to find the angle that you're talking about? We're going to add the arcs and divide by 2. It is not a central angle. And I think a lot of people treated it like it was a central angle. But when you add those arcs and divide by 2, you get 130 degrees. Is that okay for 7C? That is not a central angle because you need to look at where the vertex is. The vertex is not on the center, and so you need to treat it like an interior angle. All right, I'll do 10 and then I'll go to 12 and 14. So let's look at number 10. So this is one where we're going to use whole times external equals whole times external. So looking at this one right here, the whole is 11x, and the external is 8x. Looking at this one here, the whole is x plus 10, and the external is 8. So we've got 88x squared equals 8x plus 80. This is a quadratic that we're going to have to factor. 88x squared minus 8x minus 80 equals 0. All of those terms, every single term has an 8 in it. So I can pull an 8 out. If I pull an 8 out, I've got 11x squared minus x minus 10. So I actually don't need to use that 8 anymore. Now I can factor. I'm going to put 11x here. I'm going to put x here. I need to make a -1, and I need to use a 10. Oh, 11 minus 10 will get me a -1. I want the 11 to be negative, so I'm going to put a minus there and a plus there. So the solutions are 1 and -10/11. Now, I know I went quickly through that, and I know that was a lot of algebra. We don't normally factor quadratics with a leading coefficient, but you had to in this one. Let's pretend you didn't remember how to factor that. You could totally guess, check, and revise. Plug in 1, plug in 2, plug in 3, until you get to the right answer. We're obviously not going to use the negative answer, so the answer actually ended up being 1. All that work for the answer to be 1. All right, number 12. If AR is 2, RB is 8, and R is the midpoint of ND, so I'm going to call it X and X, find the following. All right, So these are chords, they're not secants or tangents, so we're going to do part times part equals part times part. 2 times 8 equals x times x. 16 equals x squared, x is 4, and then you can plug it in to find the appropriate things. So that was number 12. All right, 13. We're supposed to use the picture below. We're supposed to use it twice, okay? PS is 12, so that's the whole. PR is 3. PT is 18. And we need to find PN. Oh, that's really basic. Look at that. Whole times external equals whole times external. They gave us the whole and the external. We didn't have to subtract anything. We didn't have to add anything. That one was really basic. Just do 12 times 3 and divide it by 18. You've got to memorize these rules before Friday. You have to know these rules. All right, I think we're moving on to number 3. Sorry, we're jumping around. 5, 4, 3. All right. RC is 15. AC is 3. EC is 5. This is exactly like the one I just did. Whole times external equals whole times external. We didn't trick you at all. We gave you wholes and we gave you externals. You didn't have to subtract anything or do anything crazy. 5 times 15 and then divide it by 5. Sorry, 15 times 3 and then divide it by 5. 15 times 3 divided by 5 is 9. What else can I do? All right, the next one we're doing is number 6. Number 6, you need to solve for those variables one at a time. I would solve for x first, because for x, I can use this segment and this segment. I can do tangent squared equals whole times external. So that's what I'm going to do to find x. The tangent is 12. 12 squared equals, okay, I need this whole thing. Do you agree that the whole is 10 plus x? And the external is 4. Are you okay with how I set it up for x? The whole is x plus 6 plus 4. It's x plus 10. That's the whole. And then the external is 4. So 144 equals 40 plus 4x. Or you could have divided by 4. It doesn't matter. 144 minus 40 divided by 4. And you should get 26 for x. Once you have x, then you need to focus on finding y. And to find y, you're doing part times part equals part times part. So I would do 4 times y, because those are in the same chord, equals 26 times 6, because those are in the same chord. Does that answer your question, Albert? All right, and last one. Let's work number 11. Unless y'all see another one you want me to work. All right, since this segment has tick marks and this segment has tick marks, if I call this one x, then I'm going to call this one x. We're going to use tangent squared equals whole times external. Tangent squared equals, what is the whole? The whole is 2x, and the external is x. So 64 equals 2x squared. divide by 2. 32 equals x squared. And then you need to factor tree 32. 16 times 2, 16 is a perfect square. A 4 escapes and a 2 is left. Any more problems?